So hello guys, in this lecture we'll cover the topic mechanism of current conduction in metals. Okay, up to until now we have complete 9 topics and in 3 lecture, this is lecture number 4. We are covering basic electrical parts, okay, of BTech electrical engineering. This is helpful for any engineering exam as well as for BTech MTech students and for your any electrical interview of your job. Okay, so let's start. Today's topic is mechanism of current conduction in metal. Okay, metal means metal body or metal wire, you can say. So how current conduct in a metal or in a metal wire. Okay, so every metal has huge number of free electrons. Free electrons we have covered in our previous videos, you can check. So every metal bodies has huge number of free electrons, and those free electrons like continuously move. Okay, just like here you can see, suppose this is one gas cylinder. Inside gas cylinder the gas particles just collide with each other. Okay, continuously they collide with each other. Like that, in a metal body, if free electrons of this metal it collide with each other continuously, and it's happened continuously, but no electric flows. Okay, electric does not flows. If you touch any simple metal body, good conductor, if you touch it normally, there is like you will not feel any shock or anything, because there is no current flowing. Okay, uh, current flowing means there is no electron is flowing anywhere, but those free electrons are moving, continuously moving. But why there is no current? Because the average speed of free electrons wait, because like they are they are colliding with each other, and colliding with each other, and their direction of collision is like, suppose this is one gas particle, this is one gas particle, this is one gas particle, this all are gas particle, they are colliding with each other, and their direction of flow is always changing because of collision with collision. Continuously it's colliding with each other, so there is no particular direction. Okay, and average direction is like zero, means average acceleration, sorry, average acceleration of this collision is 0. Okay, because all particle of free electrons of metal, electrons are colliding with each other. Okay, continuously, let's clear it. And the direction of electron is like continuously changing. Suppose here is one free electron, so from here the direction of this electron will change. Okay, and the average speed of free electrons, average speed of free electron is almost nearly 10 to the power 5 millisecond inverse. Okay, is high at room temperature. Okay, the speed of this free electrons is high at room temperature, but there is no electricity. We'll discuss that one. At random motion, free electrons collide with positive ions. Okay, electrons and protons are there, and the collision is there is collision between electron and proton means positive ions. Okay, there is because in a metal body there is positive ions also there. a change of direction of motion. So you can understand, I think, that one easily. When one electron is collide with some other electron, or with some positive ion, the direction automatically change because of the collision. Okay, we are talking about inside one metal body, and collision of electrons and positive ions, protons, and change direction of motion. Okay, random motion average random motion average of all free electron is 0. So this is the reason if you touch one metal body, good conductor, even if it is a good conductor, suppose this is a copper, if you touch a copper conductor, there is you will not feel any shock, or there is, like, how can I say, there is no flow of electron. Still there is free electron, and those free electrons are moving continuously, colliding with each other. But it's so what is the two direction main thing? This one is also one, and this one is also one. These two main thing, because of these two main thing, if you touch any good conductor, even if you touch a good conductor, you will not feel any shock, or there is no flow of current in normal condition, okay, at room temperature. So random motion average of random motion means the random motion means this the free electrons are moving continuously. That is the random motion. Average random motion of all free electrons is 0. Okay. Then no net flow of charge or electricity in any particular direction. We just said that one, that no net flow of charge in any particular direction because of these two condition. Okay, because of these two condition. If you have any doubt, you can comment in comment section. And no current established, because of again the same these two reason. Still suppose one good conductor is there, but in normal condition it does not has any current established, means there is no flow of current. Okay. So now here we have assumed one copper wire. Okay, copper is good for conducting electricity. Okay, good conductor of electricity. Copper is a good conductor of electricity. We have assumed there is one copper, and there is one copper wire, this one, and a voltage applied or potential difference is applied in it. Okay, this one positive and negative. Positive terminal, negative terminal. So current will flow in this direction. We will talk about that one. Okay, so voltage applied at first condition, voltage applied to this copper metal. Okay, and free electrons move toward positive terminal. These free electrons of copper, we said this copper is good conductor. Why? Because of the valence electron. Valence electron are the outermost part of any atom. Okay, outermost part electrons of any atom, because those electrons are called free electrons, which are loosely tied, means can be easily removed. Okay, we talk about that in previous videos. So free electrons move towards positive terminal when we applied voltage to this copper conductor, copper metal. So collide with positive ions. We know that one, these electrons are continuously colliding with each other, and with positive ions as well as with positive ions. So now voltage applied, so it again like it's colliding with positive with positive ions. So the average time that an electron spent between two collision, the average time that an electron spent between two collision is called relaxation time. Okay, suppose here is one electron and here is one electron, here is one electron. How to say two collision? This suppose there is like so many electrons are there, but we are assuming here only 3 electrons. Suppose this electron will collide with this electron, and then it will change the direction and collide with again with this electron. Okay, so what it's saying, the electrons spent, the average time that an electron spent between two collision is called relaxation time. Means this electron collide here, from that time, suppose it collide at 0. Suppose it collide at x second. Okay, then after few second, after few time, it will collide with again, this electron will collide with again this electron at y time. Okay, so this x minus y, this is the average time. Here it is not average time, here it is a particular time for only this electron. Okay, only this electron, but if we calculate the average time, so this x minus y time is called relaxation time or tau. Okay, relaxation time or tau. So I think you guys understand. So what is the relaxation time? Relaxation time is between the two time is the average time between two collision of an electron. Okay, and it is 10 to the power minus 14 second. Okay, now drift velocity. Applied electric field. Applied electric field means this voltage applied to a copper metal. So that applied electric field provide a small constant velocity, towards positive terminal, Okay, so what is drift velocity? Applied electric field provide a small constant velocity toward positive terminal. Means, I think, okay, let's clear. When you applied voltage, okay, when you applied a suppose normally this copper wire is like a free electrons of this copper wire are colliding with each other, but the average random motion is 0. Okay, average random motion of these free electrons are 0. If it's not able to flow to any particular direction, but when you apply a voltage or electric field, it provides a small constant velocity towards positive terminal to those electrons. Okay, to those electrons means when we apply the voltage, these electrons get some velocity so that they can move towards this positive terminal. Okay, they start moving, and these free electrons start moving to the positive terminal. So that is called drift velocity. So drift velocity is always greater than the random motion of free electron. Okay, the random motion of free electron. Otherwise, if means only when the drift velocity is more than the random motion of free electrons, then those free electrons are able to move. Otherwise, there will be no flow of electrons and there will be no electricity. Okay, no current. So drift velocity is that velocity in which velocity those electrons start moving towards a positive terminal. Okay, I think you guys have understand. I'm trying to express these things very easily. Let's see. Drift velocity, let's say again, drift velocity is the velocity that provide these free electrons so that these free electrons can move towards positive terminal, and this drift velocity come because of voltage applied to the metal. Okay, voltage applied to the metal, and current is flowing through this direction. Okay, electrons are moving this direction, current is flowing this direction. So definition of drift velocity: the average velocity with which free electrons get drifted in a metallic conductor under the influence of electric field is called drift velocity. I think you guys understand. Same thing, the average velocity of with which free electrons have average random motion, but it crossed that average random motion and it got a velocity because of which it can it goes the power of means power, you can say, yeah, it goes the energy or power or whatever if you want to say, so that it able to move towards positive terminal. Okay, that is called drift velocity, Vd, and it has one particular direction. So okay, and all this happen because of the drift velocity is present there because of what, that voltage is applied. Okay, or electric field is applied. So voltage, at first voltage applied, then free electrons start moving. Okay, voltage applied to a conductor, voltage is applied, to a conductor, this one is conductor, voltage applied to this conductor, then free electrons start moving toward this direction, electrons are coming this direction to positive terminal with drift velocity, with a velocity that is called drift velocity, and drift velocity comes because of voltage applied. Drift velocity is always greater than the random motion of free electrons in a metal body at normal condition. So the drift velocity is entirely responsible for electric current in the metal. So when drift velocity, when those free electrons got that drift velocity, then they start moving towards positive direction, that means current started flowing, okay, through that metal. So the drift velocity is entirely responsible for electric current in the metal. If there is no drift velocity, so there will be no flow of current, or the conductor will not flow any current. Okay, so now there is one practical question: if electrons drift so slowly, suppose if those electrons drift this metal, voltage applied, okay, voltage applied to this metal, suppose the electrons of this metal drift so slowly, how the room lights turn on so quickly when switch is closed means when you turn on a switch, like so quickly the light turn on. Okay, so suppose it can come in mind that if the drift velocity of those electrons is slow, then how so quickly light come when it's turn on switch? So answer of that is the propagation of electric field take place with speed of light. Means when we applied electric field, that thing applying of electric field, that one is like so quick thing. Okay, suppose this one is at first disconnected here, disconnected, this one is disconnected, then we connect it and electric field is applied, then electric field is applied to this metal. It's like so quick. When the circuit is closed, full metal body is connected with the electric field. That take place with speed of light. Okay, electric field take place with the speed of light. When electric field applied to wire, this metal body means metal wire, we can say, the free electrons in the wire begin drifting almost at once. Okay, this in this full metal body, in every place drifting of free electrons started begin at almost same time. Okay, almost same time, with the speed of light, the electric field is applied. Okay, the propagation of and the speed of light is here you can see so kilometer per second. This is too fast. Okay, so there is no chance that suppose if you applied electricity, or if you applied voltage, and if you turn on applied voltage mean you turn on this switch. Okay, you turn on this switch and light will turn on so slowly. There is no chance, because you can see here the speed, it works with this speed, it's too much. Okay, so thank you guys for today. This is the topic we have covered today, the topic mechanism of current conduction in metal. In next lecture we will complete the topic of relation between current and drift velocity. So next lecture will be relation between lecture 5. It will be lecture 5, relation between current and drift velocity and some numerical. Okay, plus some numerical problem. This will be our topic for the next lecture, or lecture number 5. So I would like to request you guys subscribe this channel, so that when I'll upload videos you will get the notification fast. Okay, so bye bye guys.